Hey everyone, in this video we're going to discuss section 3.2, which is about proving trigonometric identities. Now, you might be hearing the word proof, and you might be having a flashback back to your geometry days, for better or for worse. Don't worry, these proofs are not the same. So proof is actually a really important component of mathematics, where we seek to use facts and theorems to say that some sort of statement is true. So a trig identity proof is going to aim to prove the equality of two trigonometric expressions, okay? Really, this is no different than what we've been doing when we were just simplifying a trigonometric expression. Just now, the added bonus is you know what you are trying to simplify to. You actually have an answer that you're trying to match, okay? So I think trig proofs are better than what we were doing in the past, okay? We do have some tips for trigonometric proofs. So first, we're going to select one expression or one side in the identity to with which we're going to begin. Okay, so what that means is that we're either going to start with like the left-hand side or we're going to start with the right-hand side. Okay, your goal is to manipulate the expression until it's equal to the other. Okay, so simplify it down until it matches the other. The big thing that's important for us is we can only work from one side of the identity to the other. Okay, so what that means is that we cannot manipulate both sides and meet in the middle. So what I can't do is I can't do anything where I'm like subtracting something from one side to the other. That's not how it works, okay? We're either choosing one side and we're trying to manipulate it to match the other, or choosing the other side and trying to match it to the other one. Okay? Let's see. We're going to rewrite our expression after each operation. Otherwise, it's impossible to grade your work. So what that means is that we're going to make one small change at a time. Seems tedious, but that's going to help me out in the long run, so I know that you know what change you're making and like why you're making it. If you make 4 changes at once, I'm not really going to know what happens. It's usually best to begin with the most complicated expression and work towards the least complicated expression. It's usually easier to eliminate or get rid of terms than to try to create those. That's a sometimes, though that's not always true. If you're stuck, sometimes it can help to convert the entire expression into sines and cosines. Okay, so that's something that is often helpful to us. Combining fractions using common denominators is another typical key that we'll use. We'll use the algebraic identity for a difference of 2 squares to set up Pythagorean identities. And we'll always be mindful of what the proof expression is. So it's easy to forget where you're going. So we're always going to try to figure out, okay, where am I starting and what am I doing? Okay, so first we have this idea of an identity. And remember, an identity is just some sort of, how did we define it in the other expression? In the other section, we said that the identity is just a statement that's true for all possible values. So what this first question is asking is that it's saying that is this expression always equal to cosine of x. So what we're going to do is we're just going to see if cotangent of x over cosecant of x is always equal to cosine x. Okay, so what I'm going to do is I am going to start off by taking the more complicated side, and I'm going to manipulate it around. So cotangent of x divided by cosecant of x. That's what we're trying to find. Okay, so one thing that they said was helpful was to try to convert into sine and cosine, and I think that's really helpful here. So I know that cotangent is cosine of x over sine of x. Cosecant of x is 1 over sine x. Okay, I see that I have some sort of fraction within a fraction, so I'm going to go ahead and multiply by the reciprocal of the denominator. Okay, when I do that, I see that I have a quantity of sine in the numerator and the denominator, so those will divide to be 1, and I am left with cosine of x. So in this case, this was an identity for cosine of x, because when I manipulated it, it gave me cosine of x. So that's really what we're going to be doing within our trig proofs, okay? We're going to have some sort of equality. We're going to choose one side of it, and we're going to manipulate it to see if we can get what the other side was equal to. All right, so we're going to do a couple of examples in this video. Won't do all of them. We'll do some of them when we come to class next. So example 2, we're going to verify the following identities. So first one we're looking at is tangent of x is equal to cosine of x over cosecant of x minus sine of x. So one thing that's usually helpful is to choose one of those sides. I always like to define this as the left-hand side and then the right-hand side. And usually I try to look for the more complicated one to at least give me a starting place. So I think the right-hand side is the more complicated one, so that's the side that we're going to manipulate, and we're going to try to get tangent of x. So when I go to write this, I always like to just state which one I'm starting with. So I'm starting with the right-hand side. why did I write LHL? This should be left-hand side. There we go. Okay, so the right-hand side was equal to cosine of x over cosecant x minus sine x. All right, so here we go, trying to make this be tangent. So first I see that I have cosecant of x, so I'm going to have cosine of x over, I'm going to just convert this to be 1 over sine x minus sine x. Okay. From here, something that's usually helpful, like in the denominator, I'm seeing that I have a term that's in a fraction form. It has a numerator and denominator minus another term. So I'm going to call this sine of x over 1. And then I think it might be helpful to try to get a common denominator, because if I can get the whole denominator to have a common denominator, I can multiply by the reciprocal. So it looks like my common denominator would be sine. So to get this term, my second term, to have a denominator sine, I'm going to have to multiply by sine of x over sine of x. So when I do that, I still just have my cosine of x in the numerator. In the denominator, I'm going to have 1 over sine x. And then I'm going to subtract, I have a sine squared x over sine x. Okay. From here, since I have a common denominator with these two terms, I can go ahead and combine this into one term. So I'll have cosine of x over 1 minus sine squared x over sine x. Okay. Now, from here, we do have a couple of options. So one thing that I am noticing is I'm noticing that I have this term of 1 minus sine squared x. And that should kind of stand out to us as being a potential identity. So on my trig identities sheet, I know that 1 minus sine squared x is equal to cosine squared x. So I'm going to go ahead and make that substitution here. So I'm going to have cosine x over cosine squared x over sine x. All right, now from here, I see that I kind of have a fraction and a fraction, so I'm going to go ahead and I'm going to multiply by the reciprocal of my denominator. Hopefully you're writing a little bit smaller than I am. So I'm going to have cosine x over 1 times sine x over cosine squared x. Okay. Now from here, I see that I have a couple different factors of cosine. So I have one factor of cosine in the numerator. I have 2 in the denominator, so I can go ahead and reduce that by 1. So that's going to leave me with sine x over cosine x, which we do know is equal to tangent of x. So this was equal to our left-hand side, so I know that we are done. Okay. So before I go on to the next example, I just want to point out a couple of things to you. So one thing that we did was it was helpful to kind of turn this into sine and cosines. Okay, so we called that cosecant of 1 over sine x. We did use finding a common denominator between our two terms. We looked and we found a Pythagorean identity. We multiplied by the reciprocal, and then we can reduce from there. Now, there are a couple different ways that we could have gone about this, okay? So with trig proofs, there's not only one correct step to get you there. Sometimes you might go on a wild adventure and do it in 20 steps, and maybe somebody else found 4 steps to do it. So as long as you get to the right answer, what we're trying to get to, that other side at the end of the day, that's totally fine. Just know that there's different ways that you can get there, or different orders you can go in. Okay? All right, we're going to go ahead and we're going to look at our next example. I'm going to make a copy of this page, though. Let's see. I want to duplicate. How do I do that? Okay. I needed more space. So next one that we have is we have secant x over cosecant x minus secant x over sine x, and we're trying to make that be negative cotangent of x. So again, I think that it's helpful to usually start with the more complicated side. In this case, that's going to be my left-hand side. So my left-hand side is equal to secant x over cosecant x minus secant x over sine x. All right. Okay, here we go. So again, something that's usually helpful, at least that I find to be helpful, is to convert this into sine and cosines. So this would be equal to 1 over cosine x over 1 over sine x minus 1 over cosine x over sine x. And I can call that sine x over 1 if I really wanted to. Okay, I see that within that I have some fractions and fractions, so we can go ahead and multiply by the the reciprocal of the denominator. So for that first term, that would give me sine x over cosine x. And then for my second term, if I multiply by the reciprocal of the denominator, that's going to give me a 1 over cosine x sine x. Okay. So let's see, from here, I think that it might be helpful to get a common denominator. I already have the cosine portion of it, but my first term needs to have a sine x. So let's go ahead and multiply by sine x over sine x. Okay, so when I do that, in my numerator, I'm going to have sine squared x over cosine x sine x. And then my second term stays the same, 1 over cosine x sine x. Okay, since I have a common denominator, I can combine these two together. So coming back over here, I'm going to have a sine squared x minus 1 over cosine x sine x. All right, okay, so I see in my numerator now that I have what looks to kind of be a Pythagorean identity, right? I have a sine squared x minus 1. However, if I go to my trig identity sheet, I don't actually see that order. I have a 1 minus sine squared x, but nowhere am I seeing a sine squared x minus 1, okay? The closest thing I have is this. Now, what that means is that I see that within both those terms, I'm just off by some sort of negative. Like here, I had a positive 1, but here it's negative. Here I had a negative sine squared x, here it's positive. Okay, so what we can do is we can manipulate this this Pythagorean identity, and I'm just going to go ahead and I'm going to multiply through all of these by a negative, okay? So if I multiply everything by a negative, I really haven't changed anything if I change everything on both sides. So this would give me a negative 1 plus sine squared x, and I see that that would be equal to a negative cosine squared x. So this is that substitution that I'm going to use for that identity. So I'm going to replace this with a negative cosine squared x over cosine x sine x. Okay, good news for us. I see that we have some factors of cosine x. So since in my denominator my cosine x and sine x are held together by multiplication, I know that I can reduce by a cosine x. So that'll get rid of the cosine x in the denominator. It'll reduce my power of cosine x in the numerator by 1. So now I'm left with a negative cosine x over sine x, which, lucky for us, cosine x over sine x is cotangent, so that'll give me a negative cotangent of x. Hey, and look what we did here. That was equal to our right-hand side. All right, okay. Hopefully we're feeling okay. Let's go ahead and we're going to switch over our page, and we'll do a couple more examples. So in example 3, same thing, we're just doing some more trig identities. So I'm going to go ahead and I'm going to look at example A. So I have cosine squared x minus 1 over cosine x, and we're trying to make that be negative tangent x over sine x. So again, usually it's helpful to maybe look at that more complex side, which in this case is my left-hand side. So I'm going to say that my left-hand side is equal to cosine squared x minus 1 over cosine x. Okay, so in my numerator, I see that I have a cosine squared x minus 1. That looks a lot like a Pythagorean identity, but it's kind of the same thing that we had from that last example. It looks like my signs are off by 1. Like the closest thing that I have is this, okay? But if I multiply through by a negative, that will give me the signs that I need to make that substitution. Okay, so cosine squared x minus 1 is going to be equal to negative sine squared x. Okay, now we're trying to make this be a negative tangent x sine x, okay? And so I'm kind of seeing a little bit of maybe where we can go. Okay, I see I have a sine over cosine, but I have a sine squared over cosine. So in this case, since I want to basically turn this into two different trig functions, what I'm going to do is I'm going to split up my numerator. So I'm going to have a sine of x times another sine x. I'm going to expand it over a cosine x. Okay, And then, since I see that I have one term in the denominator, but my two terms in the numerator are being multiplied, what that means is that I can split them up. So I know that I can group my cosine of x with one of those sine of x's. Okay, so if I did that, I would be left with a negative. What I circled in green is going to be a tangent x. And then what I'm left over with is just a sine x. Okay, there's only one cosine in the denominator, so I can only group it with one of those terms. So I have a sine x left over, and hey, that's equal to our right-hand side, which is exactly what we wanted. All right, hopefully we're feeling good. So far, so good. Guess I'll check in with you when we get in class. Okay, looking at our next one, so I have 1 minus sine of beta plus 1 plus cosecant of beta is equal to cosecant of beta minus sine beta. Okay, so don't let the fact that our variable is no longer an x and it's a different Greek letter freak you out. It's just a beta. It's going to do the same thing, okay? So in this example, if I'm kind of looking at maybe what my more complex side is, it's probably, again, the left-hand side. Not always the left-hand side, but I see that because I have like multiple terms and, you know, my right-hand side only has 2 in it. So let's start with the left-hand side. My left-hand side is equal to 1 minus sine of beta plus 1 plus cosecant of beta. Okay, so where are we going to go with this? Well, I see that what I'm trying to get to does not have any parentheses, so what I think we should do is I think we should distribute this through so we can get rid of our parentheses. So when I do that, I'm going to have a 1 plus cosecant beta minus sine beta minus sine beta cosecant beta. Okay, sweet. So I see kind of the start of what I want to get to, right? I have a cosecant beta and then minus a sine beta. So what we need to do is we need to try to eliminate these other two terms. So let's see how we'll do that. Well, I know that sine beta and cosecant of beta are the reciprocal identities of each other. So I'm going to have a 1 plus cosecant beta minus sine beta. And then if I turn my cosecant into that reciprocal identity, I'm going to have a 1 or minus sine of beta times 1 over sine beta. Okay, I see that those two terms are going to reduce down to 1. So I'll have a 1 plus cosecant beta minus sine beta minus, all we're left over with is 1. And then I have a positive 1 and a negative 1, so those will reduce, those will add to 0. And so I'm left with a cosecant beta minus sine beta, which is exactly what we wanted. That was equal to our right-hand side. Okay. Moving on to our next one. I want you to go ahead and pause the video. I want you to try out C by yourself. Okay, unpause, we'll go over it together. But you know what you should get, so try it out. All right, welcome back, everyone. Hopefully you had a chance to try that out. If I was going to go about doing this again, I'd probably start with the left-hand side because it's the more complicated one. If I do that, I know that I'm trying to manipulate that to be secant squared x, so you know what you should get. Where I probably would have gone with this starting off, tangent squared x. Okay, first I see that in my denominator I have my Pythagorean identity. I know that sine squared x plus cosine squared x is equal to 1. So I'd have 1 plus tangent squared x over 1. And then I know that 1 plus tangent squared x is another Pythagorean identity. Or is it 1 plus tangent x is equal to secant squared x. So I'll have secant squared x over 1, which is just equal to secant squared x, which is equal to our right-hand side. Hopefully that went well for you. All right, last one we're going to do in this video is we're going to do D. So we have cosine of beta over 1 plus sine beta, and that's equal to 1 minus sine beta over cosine beta. All right, okay, so kind of ending off with maybe one that's a little bit more complex, but in this case, I think that either way we look at it, they're kind of similar in difficulty, right? So because they're both a little bit more difficult, or they're so similar that it's not really easy, like one's easy and one's a little bit more hard. It really doesn't matter which one we start with, okay? So just since we started with all of the ones that are on the left-hand side, I might just do that one just for continuity's sake, but I also think that starting with the right-hand side would be basically just the same thing as before, okay? So my left-hand side is equal to cosine beta over 1 plus sine beta. Okay, so if I see where we're trying to go, basically I need to find the reciprocal of this. I want my sine of beta to be on top, I want my cosine of beta to be on the bottom, and I want the sine between the sine between the 1 and the sine of beta to be opposite. So instead of adding, I want to subtract. So one way that I think that we can accomplish this is so if I see that I have my 1 plus sine of beta in the denominator, that looks kind of similar to where, and I wrote all over this, it kind of a little bit looks like this, like a 1 minus sine squared of x, right? Well, and I can turn my 1 plus sine of beta into this if I think about this as a difference of squares, right? 1 minus sine squared x is really 1 minus sine of x times 1 plus sine of x. So it's if it's a difference of squares that I'm trying to get to, what I need to do is I need to multiply my numerator and my denominator, my term, by kind of that opposite factor. So there's a name for it. What is it? If you think of it, let me know. It's not coming to me off the top of my head. So 1 minus sine of beta. Is it the conjugate? It's the conjugate. 1 minus sine beta. Okay? So what I'm going to do is I'm going to multiply by that. And I see that that might be a good first step because look at what I'm introducing in the numerator. I'm introducing a 1 minus sine beta. Okay? So when I go about simplifying this, okay, in my numerator, I'm going to have a cosine beta over 1 minus sine beta. And in the denominator, I have a 1 plus sine beta times 1 minus sine beta. So if I were to distribute this and then combine my like terms, that's a difference of squares. So I'm going to have a 1 minus sine squared beta. All right. Okay, so from here, I see that I've introduced my 1 minus sine beta. What I need to do is I need to get rid of the cosine beta from the numerator, and I also need to introduce a cosine beta into the denominator. Good news for us is that 1 minus sine beta is a Pythagorean identity. Let's see. So I know that 1 minus sine squared x is equal to cosine squared x, so I can make that substitution. Okay, and so now I see I've introduced that cosine beta into the denominator, and that's also going to allow me to eliminate one of those from the numerator. So what I'm going to be left with is my 1 minus sine beta in the numerator, and then I have a single cosine beta in the denominator, which does match our right-hand side. All right, so not sure exactly how long this video is. Hopefully it's not too long, but we're going to stop there for right now. And so what you're going to see if you turn over your next page is we have 2 more pages of trig identities. So what I want you to do before coming to class is I want you to look at and attempt as many of these other examples as you possibly can. Okay, there's going to be some other twists in them, some other little facts that we're going to have to kind of introduce in class, but I want you to try them out to kind of figure out, okay, which ones can I get by myself and which ones am I getting stuck at? When you come to class, we'll go over it and then we'll finish out all these examples, but I want you to try to figure out which ones are the most complex, so that way we have an order of which we're going to look at them as. We're going to look at the most complicated ones first, and then the ones that we feel like we were pretty good to get, we'll look at those last. So that's your task, is to finish out these examples or try as many of them as you can. You might want to write in pencil or write on a separate sheet of paper. So good luck, guys. I'll see you in class.